Okay, section 5.3. So we're going to take a lot of what we did in 5.1 and use it here. So in section 5.3, we're talking about adding and subtracting radicals. It's nothing crazy. It's actually like combining like terms. Okay, except in this one, I just call it combining like radicals. So we can only add and subtract radicals that have the same radical in the end. Like I can take a square root of 2 and add it together with another square root of 2. I can take a square root of 3, add it together with another square root of 3. See how both of them have the same radical. They're like radicals. But I cannot take a square root of 2 and add it together with the square root of 6. They're not the same. It's like having two different variables. Okay? The square root of 2 is like an x. The square root of 6 is like a y. You can't put those together. Okay? So before you can do any adding or subtracting, though, you have to simplify, which is what we learned in 5.1. Okay? So I've got a couple examples. Let's start doing some adding and subtracting. Again, this is all it takes. You simplify all the radicals first and then put together those that go together. They have to match 100%, like terms. All right. So in this example, notice all of my radicals are the same. Square root of 5, square root of 5, square root of 5. Since all of these are the same, we can put them together. So what do I get when I add all these up? Now remember that there is an invisible 1. If you have a radical without a number in front of it, it really does have a number there. It's an invisible 1. So what do I get when I combine all these? Again, it's like terms, so the radical 5 stays. It's like I have a 1x plus 2x plus 3x. The x doesn't magically come together and become an x cubed. That's not how that works. Okay? So the radical 5 stays the radical 5, but what's 1 plus 2 plus 3? If you said 6 and called it 6 radical 5, you have done it. That's how adding and subtracting works. You take the coefficient that's in front of all the radicals and you add and subtract them together. But again, the only way it works is if they are the same radical. Okay? Notice these are not the same radical. So this is where that step 1 comes into play. So the first thing you're going to have to do is reduce these. So again, I use good child, bad child. So square root of 8 can reduce. It is the square root of 4, square root of 2. What is the square root of 4? That's 2 square roots of 2. Square root of 18 can reduce. That's the square root of 9 and the square root of 2. What is the square root of 9? That's 3 square roots of 2. And again, over here, the biggest perfect square that will divide that is 16 and a square root of 2, because 2 times 16 is 32. What is the square root of 16? That's 4. So all we have to do now is look at what we got. Everybody's reduced. Are these radicals the same? Yes, they are. So all we got to do is add the numbers in front of them because it's all addition. So what's 2 plus 3 plus 4? 9 square roots of 2. That's it. That's what adding and subtracting is like. So I got just a couple more. So I want you to look at the problem, pause the video, give it a shot, and then we'll walk through them. Okay? So here's the next one. Go ahead, pause the video, give it a shot. Okay, so just like before in 5.1, let's take and separate this out. So we've got the square root of 75, square root of x to the 9th. Let's go ahead and take care of this. Square root of 75 can break down. It's the square root of 25 and the square root of 3. What's the square root of 25? That's 5 square root of 3. Okay, right here, you can write out your 9x's, or again, I'm just, because I don't want to write out 9x's, that's just crazy. I'm going to take 9 divided by 2 because we're circling pairs. What's 9 divided by 2? That gives us 4 point blah, blah, blah. So that's how many x's escaped. So I've got x to the 4th. And because I have a decimal, that means I have some left over inside. So we multiply and then subtract. 2 times 4 is 8. 9 minus 8 is 1. So there was one x left inside. So now if we put this all back together, like what we did in 5-1, a 4 and an x to the fourth are out front. Underneath the radical, I've got 3x. So we come over here. We're going to do the same thing again. Okay, we already know that we have an x out front, so that's going to stay. But now we've got this square root of 48. And we've got the square root of x to the 7th that we're going to take care of. Okay, square root of 48, that's going to break down into the square root of 16 and the square root of 3. What is the square root of 16? That is 4. What square root of 3 stays because it's the bad child. Over here, again, I could write out my 7x's and circle my pairs, but I'm lazy, so 7 divided by 2. That gives me 3 point blah, blah, blah. So that's how many x's escaped from that jail. And then 2 times 3 is 6. 7 minus 6, there is 1 x left over. So if I write this out, notice I already have 1 x that escaped. This is kind of like a getaway driver outside the jail. How many pairs of x's are joining him? 3. So how many x's technically escaped? 4, because I had 1 that was waiting, 1 set of pairs that was waiting, and I had 3 pairs that escaped. So that's 4 pairs that are out of the jail. Okay? Or you can think about it as x times x to the third is x to the fourth. There's also a 4 that escaped. That's in front. Okay? And then inside the jail, we've got the square root of 3x. So there's addition between this. Can these guys get together? Well, now that we have variables out front, you also have to take that into consideration. So in here, what I'm looking at as far as are they like terms, I've got x to the fourth, square root of 3x. Is this the same as that? Yes, I've got x to the fourth, square root of 3x. If this had been an x cubed, we would not have put these together. But because this is an x to the fourth, and this is an x to the fourth, see how all the variables match. The x to the fourth matches the x to the fourth, and the radical matches. So when you're looking at adding and subtracting, make sure that if you have stuff that's out front, if it's a variable, all variables out front have to match on everybody to put them together. So in the end, what do we get? Well, what's 5 plus 4? We get 9 x to the fourth, square root of 3x. There you go. Go ahead, pause the video, give this one a shot. All right, so just like what we did a moment ago, we're dealing with cube roots. So in this one, it's the cube root of 64. And we have the cube root of p to the fourth. The cube root of 64, that actually is a perfect cube. And the cube root of 64 is 4. Over here, again, I could write out my p's. P times p times p times p. Because it's a cube root, I'm circling triples. So I had one group of p's escape. And there's one p that was left inside. So right there, you can see what our first piece is. 4p, cube root of p, cube root. Okay. Then over here, we're going to separate this. Cube root of 27 and cube root of p. Cube root of 27 is a perfect cube. That is 3. Cube root of p, there's only one p and it takes 3 to escape. So that guy's actually going to stay the way it is. So we have 3 cube root of p. And there's a plus sign between this. So the question is, do these match? Are these alike? Now, they both have a cube root of p, but notice this one has a p in front. Does this one have a p in front? And the answer is no. So can I put these together? No, because they are not alike. All of this had to match everything over here. And since this has a p, this guy right there, and this one does not, you cannot put these together. So the final answer is actually just what we had right there. 4p cube root of p plus 3 cube root of p. That is the final answer. All right, I think I have one more. Yep. Go ahead, give this one a shot, pause the video, and that will wrap up 5.3. All right, cool thing about this is notice that all these are the same radical. So technically, we could actually put these all together. But before we do that, you really do need to reduce these. So we really do need to take care of this 6th root of y to the 7th. Okay, so that's really y times y times y times y. I don't really like writing out 7 y's, but I'll do it for this one. So what? Notice my tail gets bigger as I go along. Silly me. So in order to escape, you got to be in a group of 6. Look, a group of 6. So this guy reduces to y 6th root of 1y left behind. So all of these pieces up here now look like 2y 6th root of y minus 3y 6th root of y minus 11y 6th root of y. Do all these still match as they did in the beginning? You bet. They're all y 6th root of y's. So I can put all these together. And it is okay to have a negative number in front of a radical. So what's 2 minus 3? Well, that's negative 1. And negative 1 minus 11 gives us negative 12 y 6th root of y. And that's how we add and subtract radicals. Simplify first, and then combine like radicals if it's possible. Thanks.